Welcome students to online classes of mathematics for class 9th. In this video we are going to study the chapter number 6, which is lines and angles, and we will cover the introduction part of this chapter. This is session number 1 for this particular chapter. Myself Deepak Gautam, TJT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. So first we will look at some basic terms and the definition before we start of the exercise. Okay, so these are the basic terms which we have already studied in your previous class, in previous classes. Okay, just we are going to recall them and revise them. So first one here is a line. Simply a line is a breadthless length with no endpoints. Okay, you must have seen a line. Okay, a line does not have any endpoint. That means it goes continuous in both direction. Okay, and we consider it as a breadthless length. That means a line does not have any thickness, as the definition given by the Euclid's. This is the definition given by the Euclid. Okay, he stated that line is a breadthless length and it does not have any endpoint. That means whenever you are to draw a line, you will always put arrows on the both end, which means or which indicates that the line is going continuous in the both direction. Okay, next we have line segment, which is a line segment, a part or the portion of line with two endpoint is called line segment. So line segment is simply if we take out a part of this line. Okay, if we take out this part of this line, let's say here, then it will be like this. That means now it will have two endpoints. Let's say this one is A and this one is B. So line segment is simply a part or portion of line with two endpoints. Okay, we will not put the arrow on either side. We'll just put the endpoints, which means this line is terminating at both the end. Okay, A and B. Next we have ray. A ray is a part of line with one endpoint is called a ray. That means again a part of line. That means if we take this part of line, this part, so this will be like this. It will have an endpoint, but it will be going continuous in the other side. So all the such lines are called ray. Okay, let's say this have a start point, or you can say end point. This is also called the initial point or the end point. Initial point or end point, while it is going continuous in the other direction. So the basic difference between the two is a line have arrow on the both side. This is line. Then we have line segment, in which we don't have any arrow on both sides. Instead of that, we have endpoints, while a ray is we have one endpoint and it goes continuous in the other direction. Okay, so this is line segment and the ray. Moving ahead, now we have collinear and the non-collinear point. Okay, collinear stands for, this co means common and linear means line. Okay, points are points. So simply this word says the points which are on common line. Okay, that is three or more points lying on the same line are called collinear point. Okay, three or more points which lie on the same line are called collinear point. As you can see here, if we draw a line, let's say like this, and it's having certain point, let's say a point here A, a point here B, and there is another point on the line C. As you can see, these all 3 points are lying on this same line, so they will be called collinear points. Okay, if there is another point, let's say this one, if we have a point here D, we have another point here E, all these points are lying on the same line, so these points will be termed as collinear points. Next we have collinear point, non-collinear point, which is the opposite of the collinear point, which means the points which do not lie on the same line are called collinear point. Suppose we have a line like this, and it has 2 points A here and B here. Okay, then there is another point, let's say C here. Now you can see this point C is not lying on the line, so you can see point A, B, C are not collinear because they are not lying on the same line. If you are to connect A to C, that will be a line like this, but it will miss out the point B. Similarly, if you connect B to C, that in that case it will miss out the point A. So these points are not on the same line. At least one point will miss out. So such points are called non-collinear points. Okay. Moving ahead, next we have angle. This is something you've been studying from class 6. So angles is when two rays originate from the same endpoint, they forms an angle. Okay, let's say we have two rays which originate from the same endpoint. So we have one ray here, and there is another ray which is also originating from this same point, like this. Okay, so let's put the arrow on the other end, and they are starting from this point. So as the definition says, when two rays, these are the two rays, originating means starting from the same endpoint, their endpoint is same, they forms an angle. Okay, the region between these two rays is called angle. Okay, this is the angle. Next we have arms of the angle. This is simply the rays making the angle is called the arms of that angle. That means this angle is formed by these two rays. Okay, these are called rays. So there are two rays required to make a angle. Okay, so these are the rays, while the region between the ray is called angle. Next we have vertex. Vertex is the point from where the rays originate are called vertex. Okay, the point from where the rays originate is called vertex. So this point is called the vertex of this angle. Okay, so simply it has three quantity: an angle, ray, and the vertex. Okay, the region between the ray is called angle, the arms which form the angle are called ray, and the point from where the rays originate is called vertex. Okay, it should be easier, not R. Okay, next is we have different types of angle, in which first one is acute angle. Okay, so acute angle is an angle which measure between 0 to 90 degree. Okay, the angle which measures 0 to 90 degree is called acute angle. Let's say if we have an angle like this, measuring, let's say this is 50 degree, so it is between 0 and 90 degrees, so this will be acute angle. Okay, next we have right angle, which is an angle which measure exactly 90 degrees, called right angle. That will be like this: we have a ray here, and then there will be another ray which will be perpendicular, that means at the 90 degree angle. So this is our right angle, when the measure of angle is exactly 90 degree. Next we have obtuse angle. Obtuse angle is an angle which is greater than 90 but less than 180 degree, is called obtuse angle. Let's say this one, we have a ray here, and then it is making an angle more than 90 degree but less than 180 degree. Let's say this is angle of 120 degree. Okay, it is more than 90 but less than 180, so this will be called obtuse angle. So these are the three type of angle: acute angle, which is less than 90, right angle, which is exactly 90 degree, and then we have obtuse angle, which is more than 90 degree but less than 180 degree. Okay, moving ahead, we have straight angle. Straight angle is an angle which is exactly equals to 180 degrees, called straight angle, which means when we have a, let's say, a ray here. Okay, we have a ray here which starting from, let's say, this point O, and then we have another ray in exactly opposite direction of this one, like this. So they are forming a straight line, so the angle formed is called straight angle. and it will measure exactly 180 degree. Okay, then we have reflex angle, which means an angle which is greater than 180 degree but less than 360. That means it will be like this. We have angle, we have a ray like this, and then there will be another ray like this. It is making an angle of, let's say, 150 degree. This is not 150, this will be, let's say, it will be around 230, right? Because 180 is here, it's going beyond 180, it's about 50 degrees, so it will be around 230 degree angle, which is more than 180 and less than 360 degree. Okay, next we have one important type of angles which are called supplementary angle. Okay, supplementary angles means two angles whose sum is 90 degree are called supplementary angles. Okay, two angles whose sum is 90 degree are called supplementary angle, which means if we have an angle of 40 degree, then its supplementary angle will be the angle by adding which the result will become 90, so that angle will be 50 degree. Okay, so the supplementary angle of 40 degree is 50 degree, so that the sum will become 90 degree. Similarly, if there is an angle of, let's say, 60 degree, what will be supplementary angle? Its supplementary angle will be something by adding which you will get result as 90 degree, so that angle will be 30 degree. Okay, the supplementary angle of 60 degree angle is 30 degree. Okay, so if the sum of the two angle is 90 degree, they will be called not supplementary, complementary angles. Okay, if the sum of the two angle is 90 degree, they will be called complementary angle, not supplementary. Supplementary is here. Next one, supplementary angles are the two angles whose sum is 180 degree are called supplementary angle. Now let's say if we have an angle of 120 degree, its supplementary angle will be 60 degree, which result into total 180 degree, like this definition say. So if the sum of two angle is 180 degree, they will be called supplementary angles. Okay, if you want to have if you have confusion in remembering them, you can see that C is the alphabet which come first. So this complementary angle is when the sum of two angle is 90 degree, and in English alphabet S comes later. You can relate it to the larger number, so supplementary related to the 180 degree angle. Okay, so now next we have adjacent angle. The two angle with common vertex and a common arm are called adjacent angle. Suppose we have two angle like this, one here, and there is another angle like this. If we join these two angle by joining these two arms, so it will be like this. Now in this case they have a common arm, so all such angles are called adjacent angle. That is, two angle with common arm and common vertex. It has common arm and a common vertex. This is the common vertex and this one is the common arm. So these two angles then now will be called adjacent angles. Okay, which means they have a common arm and a common vertex. Next is linear pair of angles. Linear pair of angle. It says if non-common arms of two adjacent angle forms a straight line, then they will be called linear pair of angles. That means, similarly, see from this example, let's say if we have two angles like this, and there is another angle. If we join these two lines, these two angle having this common arm, and when you join them, you will find that these two non-common arms, these are the common arms, these are the non-common arm, they are forming a straight line. In that case, these two angle will be called linear pair of angle. They will be called linear pair of angle. In short, we call them LP. LP is for linear pairs. Okay, moving ahead, we have next vertically opposite angle. This is very important. It means when two straight lines intersect each other, they form two pair of vertically opposite angle. This simply means we have two straight lines like this. Suppose we have two lines like this, and they are intersecting each other at a point. Let's say this is A, B, A here and B here. There is another line which is C and D here. Okay, this is making two pair of vertically opposite angle. That means this angle is vertically opposite to this angle. Similarly, angle this AOD is vertically opposite to the angle BOC. Okay, so this is forming two pair of vertically opposite angle. First one is angle AOC and angle BOD. Second pair of vertically opposite angle it is forming is angle AOD and angle BOC. So these are the two pair of vertically opposite angle which are formed by these two intersecting line. Let's say they are intersecting at point O. Okay, so they are forming two pair of vertically opposite angle. One is AOC and BOD. Second pair is AOD and BOC. Okay, moving ahead. Now we have two axiom. Like I said, axioms are in chapter 5 you will study that axioms are the universal truth. We don't need proof for them. Okay, so this axiom is, if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. This simply means we have a ray which is standing on a line. So let's first draw a baseline, and there is a ray which is standing over it like this. Okay, let's say if a ray, which is this one, if a ray stands on a line is this one, then the sum of two adjacent angles so formed, it is forming two adjacent angle first one this and this second one. Okay, the sum of the two adjacent angles so formed is 180 degree. That means the sum of these two angles will be 180 degree. Okay, this is what the axiom 6.1 says. If a ray, which is this one, stands on a line which is with this baseline, then the sum of the two angles so formed is 180 degree. Okay, this is axiom 6.1 says. Next is axiom 6.2, which is the converse of the axiom 6.1. It says, if the sum of two adjacent angle is 180 degree, if the sum of two adjacent angle is 180 degree, then the non-collinear arm of the angle forms a line. Okay, this says, suppose we have a line like this. So we don't know whether this line is a straight line or not, and we have a ray standing over it. This ray is making two angle, and it is given that the sum of these two angle is 180 degree. So if the sum of the two adjacent angles is 180 degree, then this baseline will be a straight line. Okay, this will be a straight line. That's what the axiom 6.2 say. Simply understand that if we are given that the baseline is a straight line, in this case this is given that this is straight line, then the ray which stand over it will make a two angle, and the sum of those two angles will always be 180 degree. Okay, though simply means agar baseline is a straight line given है, if this baseline is straight line, तो उसके adjacent angle का sum 180 degree ही होगा. और exam 6.2 says अगर adjacent angle का sum 180 degree है, then the baseline will be a straight line. Okay, अगर straight line है तो एंगल का सम 180 डिग्री होगा, और अगर 180 डिग्री है तो बेसलाइन विल बी अ स्ट्रेट लाइन. दैट्स व्हाट द एग्जाम 6.1 and 6.2 says. Okay, theorem 6.1. The statement of the theorem is, if two lines intersect each other, then the vertically opposite angles are equal. Okay, the statement of the theorem simply says, if you have two lines which intersect each other, that will form two pair of vertical opposite angle, and each pair of vertical opposite angle is equal. Okay, so like I said, whenever we have a theorem, we have to prove it. So we are going to prove this theorem. So let's first draw the diagram as this statement says if two lines intersect each other. So let's draw two lines that will intersect each other at a point. So we have two lines like this. Okay, let's name it A here and B here. Then we have this second line C and D here. Okay, it let's take the point where the two line intersect each other as O. It will make two pair of vertically opposite angle. One is angle AOC and angle BOD, and the second pair of vertically opposite angle is angle AOD and angle BOC. Okay, so whenever we are to prove this any theorem, we'll prove that in the three steps. First one is we'll write the given parts, whatever information is given in the statement of the theorem. The statement of the theorem says if two lines intersect each other, that means it is talking about two lines. Okay, we have assumed those lines as AB and CD. So let's write given is two lines. As we are not given the name of line in the statement, so we'll take let AB and CD intersecting each other, say at point O. Okay, as we are not given the name of the point where the lines are intersecting, so we'll write say at point O. Okay, forming two pairs of vertically opposite angles. Okay, which are, first pair is angle AOC and angle BOD. Second pair is angle AOD and angle BOC. So this is what given us in the question, that we have two lines, we have given those line name AB and CD, and they are intersecting each other at point O, and they are forming two pair of vertically opposite angles, which are AOC and BOD. Second pair is AOD and BOC. Now we'll write what we have to prove here. So we'll write second heading, which is to prove. To prove here is we have to prove that vertically opposite angles are equal. That means first we have to prove that first one is angle AOC is equals to angle BOD, and then we all have to prove that angle AOD is equals to angle BOC. Okay, now we'll start this proof. Okay, I'm drawing the diagram roughly here. This is A, B, C and D, and this angle is, this point is O. Okay, now you can see as ray, we are taking this ray OA standing on line CD. We are taking this ray OA standing on line OA is standing on line CD. Okay, so let's take as ray OA stands on CD, therefore we have studied in axiom 6.1 says if a ray stands on a line, it will form two adjacent angles and the sum of these two angles will be 180 degree. Similarly, this ray OA standing over CD, and it will make two adjacent angle and their sum has to be 180 degree. That means angle AOC plus angle AOD will be equals to 180 degree. This is by axiom 6.1. Okay, now ray, let's write as ray, we'll take now ray OC standing over line AB, as ray OC stands on line AB. Therefore, okay, now we are taking this ray OC is standing on line AB. Again, this will make two angles. This one and their sum has to be equals to 180 degree. So that is angle AOC plus angle BOC will be equals to 180 degree. Okay, this is also by axiom 6.1, which says if a ray stands on a line, then the sum of the two angles so formed is 180 degree. Okay, now let's name it equation 1 and this is equation number 2. Now we'll see that the sum of these two angles is 180 degree, also the sum of these two angles is 180 degree. So the sum of both the angles is 180 degree. So that means these two are also equal. This is equal to 180, this one is also equal to 180, that means they will also be equal. So right from equation 1 and 2 we get what we get that angle AOC plus angle AOD will be equals to angle AOC plus angle BOC. Okay, now you can see on both sides we have AOC and they will be, if you shift this AOC on this side will be of minus and they will be cancelled out. What remained after that will be angle AOD is equals to angle BOC. This is what we have to prove here, that angle AOD is equals to angle BOC. Okay, we have proved the one part of the two. So we'll not prove this first part. You can directly write that. Similarly, we can prove angle AOC equals to angle BOD. Okay, we will not prove the second part because the proof method is same. So we'll simply write similarly we can prove angle AOC is equals to angle BOD. Okay, so that's the proof for the theorem 6.1. We have used the axiom 6.1 here. Using that we have proved that angle AOD is equals to angle BOC, and similarly we can prove that angle AOC is equals to angle BOD. Okay, so that's the proof of theorem 6.1. Now moving ahead to the examples. We have three examples before the exercise 6.1. So let's see the first example. It says in figure 6.1, this is figure given to us, PQ and RS intersect each other at point O. We have two lines PQ, this one, and RS, they are intersecting at point O. If POR, this angle POR and angle ROQ, the ratio of these two is 5:7, and we have to find all the angles. Okay, so let's start at solution. Again, in solution we'll write first given part, the information which is given to us. We are given that two lines PQ and RS intersecting at point O. So we have two lines PQ and RS intersecting at point O, and we are also given that also the ratio of angle POR to angle ROQ is equals to 5:7. So this is what given to us in this question. We have to find, see here we are not asked to prove here anything, we have to find here. So write to find all four angles. That means we have to find measure of all four angles. Okay, so let's write its solution. Okay, instead of proof we will write the solution here. So again we are going to use the axiom 6.1. We'll take this line PQ, we have this ray or the line PQ on which this ray OR is standing over it. This is OR and this is PQ. Q. It will make two angles, and the sum of these two angles has to be 180 degree by the axiom 6.1. Okay, so we'll use that axiom, but before that we'll write let the measure of angle POR, this is POR, and angle ROQ is, we assume those angles to be in the same ratio, that is 5x and 7x. Okay, we have taken those angles as 5x and 7x. Now we'll write as ray OR stands on line PQ, therefore the sum of the two angles so formed, that is angle POR plus angle ROQ will be equals to 180 degree. This is by axiom 6.1. okay, here the angle ROQ, we have taken that angle as 5x, and we have taken angle, sorry, POR we have taken as 5x, and ROQ we have taken as 7x, and their sum is equals to 180 degree. okay, this means 5x plus 7x will be 12x equals to 180 degree, or x will be 180 degree divided by 12. This will result into 15. okay, so x is equals to 15. So now we can find the measure of all four angles. So first angle is POR. Right, hence angle POR, which we have taken as 5x, will be 5 into 15, that is 75 degree. Then we have a second angle ROQ. We have taken that as 7x, that means 7 into 15 degree, that will be equal to 105 degree. okay, so we got the measure of these two angles. Now we have the vertically opposite. We know that the vertically opposite angles are equal, so we can write also angle POS will be equals to angle ROQ will be equals to 105. This is because they are vertically opposite angles. okay, and angle SOQ is equals to angle POR will be equals to 75 degree, and the reason is same vertically opposite angle. So that's the solution of example number 1. We have find the value of all four angles. okay, moving ahead to the next example, which is a very important one. It says in figure 6.8, ray OS stands on line POQ. So we have this line POQ, this one, and there is a ray OS standing over it. Then we have another ray OR and OT are angle bisector of POS and SOQ. That means this ray OR, this one, is bisecting this angle. That means these two portions are equal. Similarly, OT is bisecting angle SOQ. That means these two portions are also equal. okay, these two angles. And we are given that angle POS is x degree. This angle POS, you can see that angle is this one. POS is x degree. We have to find the value of angle ROT, this one, ROT. okay, so let's first write the given information. So first write the given here is that ray OS standing on line POQ, a ray OS standing on line POQ. okay, and ray OR and OT are angle bisector of angle POS and angle SOQ respectively, and we are given that also the angle POS is equals to x. We have to find the measure of angle ROT. Okay, so let's start the solution. So from the question it says the ray OS is standing on line PQ. So we'll first write as ray OS stands on PQ, therefore the two angles are formed is angle POS plus angle SOQ. Okay, when the ray OS is standing, this ray OS is standing on the line PQ, it's making angle POS and angle SOQ, and their sum is will be equals to 180 degree. This is by axiom 6.1, which says if a ray stands on a line, the sum of the two angles are formed is 180 degree. Okay, and we are given that angle POS equals to x. We have angle POS is equals to x. So at the place of POX we'll write x plus angle SOQ is equals to 180 degree. From here angle SOQ will be equals to 180 degree minus x. Okay, so from here angle SOQ will be equals to, when you shift this x2 on the other side, will be minus x. SOQ will be equals to 180 degree minus x. Now moving ahead, in the same question, figure, you can see that now this ray OR is also standing on the line PQ, so it will also make two adjacent angle and their sum will be equals to 180 degree. Okay, but it says that OR is bisector. It says OR is bisector of angle POS and OT is bisector of angle SOQ. Okay, so next try to write now as ray OR bisects angle POS, therefore the angle, which is this angle ROS, will be equals to the half of angle POS. Okay, this because in question is given that OR is bisecting POS, therefore this angle POR, or you can say ROS, will be half of POS. So angle ROS will be half of POS, and POS is given as, we have calculated here, POS is given as x, so we'll write it into x, that result into x by 2. Okay, similarly the ray OT bisects angle SOQ, therefore its bisected angle, which is angle SOT, we are taking this part of angle SOT, this one SOT will be the half of angle SOQ, and SOQ we have calculated here, SOQ is 180 minus x, so it will be 1 by 2 into 180 degree minus x. When you multiply 2 inside will be 180 by 2 will be 90, and this will be x by 2. Okay, in the question we are asked to find the value of ROT. So we'll write now this angle ROT will be the sum of angle ROS and SOT. It will be sum of angle ROS plus SOT. ROS will be calculated here, which is x by 2, and SOT is 90 minus x by 2. This plus x by 2 and minus x by 2 will be cancelled out, so the answer will be, it is 90 minus. Okay, so these two will be cancelled out. What remain here is 90 degrees. So answer of this question is angle ROT is equals to 90 degree. That's the solution of example number 2. Moving to the next example, we have example number 3. It says in figure 6.1, OP, OQ, OR and OS are 4 rays. We have 4 rays, OP, OQ, OR and OS. Prove that the sum of the 4 angles POQ, QOR, SOR, POS is equals to 360 degree. Okay, so let's start. First write, let's given part. Given is 4 rays, 4 rays which are OP, OQ, OR and OS, originating from point O. Originating from point O. Okay, and we have to prove that angle POQ plus angle QOR plus angle SOR plus angle POS is equals to 360 degree. This is what we have to prove, that the sum of all 4 angles is 360 degree. So let's start the solution. Not solution, will write proof. Okay, so we'll start by, what we're gonna do is we'll extend this ray OQ in the opposite direction. It will be like this. Okay, so we'll write, before proof we'll write the, in proof we'll write, let's produce ray OQ to a point T. Let's name this point T here, to a point T. Okay, now what we're gonna do is we'll take this line QT and then there will be a ray OP standing over it. So I'll write as ray OP stands on line QT, therefore the sum of angles so formed, it is angle TOP plus angle POQ will be equals to 180 degree. This is by axiom 6.1. okay, the sum of the 2 angles so formed is 180 degree. Okay, now moving ahead, now we'll take this ray OS which is also standing on the line QT, then the sum of these 2 angles, this one and this one, will be 180 degree. Okay, so I'll write as ray OS stands on QT, therefore the sum of angle TOS plus angle SOQ will be equals to 180 degree, and this is also by axiom 6.1. okay, now you can see that this angle SOQ can be written as the sum of angle SOR and QOR. So at the place of SOQ will write, or we have angle TOS, at the place of SOQ will write angle SOR plus QOR. This will be equals to 180 degree. okay, this SOQ will be equals to SOR and QOR. okay, so we got this equation. Now let's name this as equation number 1 and this one as equation number 2. Now we'll add the two equation. So write on adding equation 1 and equation 2 we get, so equation 1 is angle TOP plus angle POQ, angle TOP plus angle POQ plus, now we'll write these three angles, angle TOS plus angle SOR plus angle QOR. On the other side, here we have 180 and here also we have 180 degree. So we have added the two equation on the both side. So now you can see that this 180 plus 180 will be 360 degree. okay, now you can see the angle TOP and angle TOS, these two angle TOP, this one, and angle TOS will result into angle POS. So these two angle will result into angle POS, and let's write the remaining angle, which are angle POQ plus angle SOR plus angle QOR, and this result into 360 degree, and that's what we were asked to prove here. okay, so we have proved that angle POS plus angle POQ plus SOR plus QOR is equal to 360 degree. So with this we have finished the all three example of chapter 6, lines and angle. Now we'll start the exercise 6.1 in the next session. So that's it for now. Thanks for joining here.